Hey guys, this is Miss Ross again. Okay, so we're doing week 13, practice 1, and I promise you we are going to shave off some time from what happened yesterday. We're going to make this much faster. All right, Henry's making some brownies and some cupcakes. If the brownies need 5 3/8 cups of sugar and the cupcakes needed 1 2/10 cups, how much sugar does he need altogether? Let's draw our bar model first. Okay, we don't know how much he needs altogether, but we do know that he's got 5 3/8 for the brownies, and he's got 2 and 1. Not 2 and 1/10, 1 2/10 of a cup for the cupcakes. Okay, so looking at my handy dandy flow chart, zooming out. Do I know the total? No, I don't. Do I have equal parts? No, I don't. So I'm going to add. Okay, I'm going to add these two together to make this number here. So I'm going to line up by the decimal. So I've got 5 3/8 added to 1 2/10. Now remember I told you in that blank hole there, put a 0 so that you don't lose your place. Add them together. Here we go. 8 plus 0 is 8. 3 plus 2 is 5. Bring down the decimal, and then 5 plus 1 is 6. Your answer is 6 58/100. There is the total of sugar that you need. All right, next one. The drama club members need to buy 367 bags of popcorn to serve during the intermission of their play. If the popcorn comes in cases of 12 bags, how many cases do they need? Okay, so you know that all total you have 347 bags of popcorn, and you're dividing it into cases to figure out how many cases you need to buy. So if you buy one case, there's 12 bags in there. If you buy another case, there's another 12. If you buy another one, there's another 12. Buy another one, there's another 12, all the way down until you used up 347 bags of popcorn, okay? So let's look at our problem-solving flow chart. Do I know the total? Yes, I do. Do I need equal parts? Well, 24, 12, 12, 12, 12, 12. Yes, I need equal parts, so I need to divide. Here we go. I'm not going to be scared to use another piece of paper because that gives us trouble when we try to do it without another sheet of paper. So don't be scared. So I've got 347 divided by 12. So 347 divided by 12. And what I like to do is to come over here and list out multiples. 12, 24, 36, 48, 60, 72, 84. That might do it. Let's see if that'll get it. And so each one of these is that's 1 12, 2 12s, 3 12s, 4 12s, 5 12s, 6 12s, 7 12s. Here we go. How many 12s are in 3? There are none. Put an X up there. How many 12s are in 34? There are 1, 2, because 36 is too much. Put your 2 up top. 2 times 12 is 24. When you subtract, you get 10. Bring down the 7. So the new number I'm dividing into is 107. How many 12s are in 107? Well, we're not there yet, so we got to keep adding. 86 plus 12 is, 84 plus 12 is 96, plus another 12 is, let's see, I'm going to put 12 right under here, 8, it's 108. Okay, so that's too many. So this is 1, 2, 3, 4, 5, 6, 7, 8. This would be 9. Okay, you can mark that out now. All right, so 9 is too many, so we're going to say 8. How many 12s are in 107? There are 8. 8 times 12, 1, 2, 3, 4, 5, 6, 7, 8. There are 96 in 107. 96, because 8 times 12 is 96. When you subtract, you are going to have to borrow because, no, actually don't have to borrow. 7 minus 6 is 1, and then 10 minus 9 is 1. So there are 11 left. So that what that means is if I'm looking over here at my bar model that I made here, I would have, these are each of these are cases that have 12 bags in each. So I have 12, 12, 12, 12. I would fill up 28 bags. They would have 28 bags, would have 12 in them. And then there would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There would be 11 little bags left, but I gotta buy a whole nother case. So there would be 28 cases total, plus I would need to buy one more to get all these 11 little bags here, which would give me 29 cases. Okay, and there's my answer. All right, next one. A team is playing 21 games. In each of 11 games, 264 tickets were sold. In each of 10 games, 194 tickets were sold. So what was the total number of tickets sold? So what you have to do is you have to solve this bullet, and then you have to solve this bullet, and then you have to add the two together. So what I want you to understand is that you don't know the total of tickets sold. So let's draw that here. You don't know the total number of tickets sold, but you do know you have two parts. Each of these bullets represents a part. You have this part and you have this part, okay? This is 11 games. The first part is 11 games where each one of them you sold 264 tickets. This part is the last 10 games where in each of those 10 games you sold 194. So you've got 11 times 264 and 10 times 194. Then those two numbers added together will give you the total of all of the 21 games. So let's come over here and let's start doing some math. Unfortunately, there's just a lot of math involved in this one. So let's start with this block first. So I've got 264 times 11. Here I go. 1 times 4 is 4. 1 times 6 is 6. 1 times 2 is 2. Okay, then I'm going to cross this number out because I don't need it anymore, and I'm going to put a 0 here because I'm about to multiply by the tens place. Then 1 times 4 is 4. 1 times 6 is 6. 1 times 2 is 2. And then you can add them together. 4 plus 0 is 4. 6 plus 4 is 10. Carry the 1. 1 plus 2 is 3 plus 6 more is 9. And bring down the 2. So in this first 11 games, they sold 2,904 tickets. All right, now we've got to figure out the last 10 games. So take 194 times 10. Miss Ross, we don't have to solve all that out because we know any number times 10, you just add a 0 on the back. That's right. So it's 194, add a 0. So that's 1,940. So this is 1,940. Now you've got the first 11 games is this much. The last the last 10 games is this much. Now you need to add them together to get the total in all. So 2,904 added to 1,940. Add them together. 4 plus 0 is 4. 0 plus 4 is 4. 9 plus 9 is 18. And 1 plus 2 plus 1 is 4. You should have gotten 4,844. And that is the number that comes up here. 4,844. Highlight it. Okay. All right. Next one. Miss Schaefer is conducting a survey to find out how many pairs of shoes each student has at home. After the children vote, how should Miss Schaefer organize her data? So this is, what type of graph is it? So just write, what type of graph? All right, so I always tell my students, ask the question, answer the question, and then see what does your data look like. So here we go. I'm going to ask an imaginary kid sitting in this classroom right now. Okay, let's see. I'm going to ask Benjamin Bima. Benjamin Bima, how many pairs of shoes do you have at home? Ben says 7. Okay, there's the number. There's my data. I'm going to ask another kid sitting in this room. I'm going to ask Abby Piner. Abby Piner, how many pairs of shoes do you have at your house? 25. Okay, Piner, you have a shopping problem. I'm going to ask another kid. Let's see. I'm going to ask Cedriana. Cedriana, how many pairs of shoes do you have at your house? 13. Okay. What is my data? My data is numbers. So numbers are numerical data, and numerical data is organized in line plots. Okay, so what you have is, what that means is you have a graph, and on the bottom you'll have the numbers. 7, you'll have 13, you'll have 25. And then what you'll do is, this is Ben, this is Cedriana, this is Abby. You put X's for the data. Let's try one more. Let's say we ask, let's ask Jayla. Jayla, how many pairs of shoes do you have? She says 13. So then this would get another X. Since there are numbers going across the bottom, this is a line plot. This is numerical data. So this is a line plot. So I'm going to come over here and I am going to highlight that. That is my answer. Okay, so numerical data is organized with line plots. All right, and last one, I told you that this part would be shorter today because we are not going to review the quadrilateral family. I'm just going to throw up the throw up the anchor chart, and we are going to talk about it. Okay, so we're going to talk about the question. So you've got the quadrilateral family. Let me zoom out here. Sorry about the fuzziness. Quadrilateral family. You got the two brothers. You've got the twin boys, and you've got the square dog. All right, so let's talk about it. If you have no idea what I'm talking about, go back and go over the quadrilateral family anchor chart. You need to write it down. Okay, so remember that the shapes are always the things that are above them. Always the things that are above, only sometimes the things that are below, and they are never the things that are not connected to them by lines. So if you don't see a line connecting them, they are never that thing. And for example, but I do want you to understand that a square is never a trapezoid because there's no line going that way, but a square is the things that are connected by line. So see how a square can go from here to here to here to here? Okay, that is a long continuous line. All right, here we go. Which statement is true? So this is going to be, all parallelograms are rectangles. So parallelograms are always quadrilaterals. They are not always rectangles. So that is a no. All quadrilaterals are parallelograms. Well, it's only always the things above it, and there's nothing above a quadrilateral, so that's not it. All squares are rectangles. So here's a square. It is always the things that are above it. That is true because a square has 4 right angles and 4 equal sides. And the only rule to be a rectangle is it has to have 4 right angles, and a square always has 4 right angles. So the answer for this is C, because all squares are rectangles because the only rule for a square is 4 right angles. All right, I think we shaved off some time from yesterday. Love you guys. Bye.